hydroxides, and carbonates. Yes? So if we add HCl, what happens to the HCl? It dissociates completely. And is there anything from this that can react with something in here? Yes, the H. Okay, what can the H react with? Carbonate. Okay, so what you'll end up with is you'll end up with H plus CO3, 2 minus, and that becomes H2CO3, so we're going to put a 2 here. And then this breaks down into CO2 gas plus H2O liquid. Yes? It does, but not a lot. Like, it depends on what the pressure, like, if the liquid is in a closed container, like, obviously not as much CO2 can escape. So let's say in your blood, H2CO3 can exist because, you know, the CO2 can't escape until it gets to your lungs, right? So at the cells, you'll have H2CO3, right? Yeah. Now, these are not the only two substances. There was one in the AP practice problems last day. Okay, so in the AP practice problems, we also had, what was it? We had something binoxalate, calcium binoxalate, CaC2O4. Or maybe it was silver. I think it was silver. Okay, so we know that H can react with C2O4 because it is a weak base. And if that happens, the concentration of C2O4, 2 minus, decreases. Therefore, the system shifts right. Therefore, solubility of Ag2C2O4 increases. Yes?
So can H plus react with any Bronsted-Lowry base?
It can react with any Bronsted-Lowry base. Okay, H plus can react with any Bronsted-Lowry base. Yeah. But just as a reminder in solubility that it does take place. Yes, yes? Algo más? Anything else?
Yeah, I would ask you.
Yes. 84 regular solubility review. Okay. Well, isn't that just the question we just did? Oh, 84. There's a problem with question 84, I think. Yeah, cross out 84 because there's two answers. A and D. Okay, A and D would both work. Yeah.
He said B.
So yeah, 84 is just a hot mess. Okay? Should be A and D, but the answer key says B. Hot mess. Cross it out. Anything else? Because the pen does weird things. Do you see this arrow up here? I am not making those drawings like that. Like I'm not. Right? It's just like, I don't know. Sometimes it just goes crazy. It's driving me bananas anyway. Yes? I would add the strong ones because why would you add a weak one? Because that just complicates matters. Yeah. And I would add a strong one that's soluble with everything like HCl or HClO4. Okay, or HNO3. I mean, Cl's not soluble with everything. It is low solubility with chloride, but it's low soluble. It's soluble with most things, right? Yeah. HNO3 is a really good choice. Anything else? Going once? Going twice? Going 3 times? Sold. All right. So we are moving on to page 14 in your acid-base book. You'll need your data booklet. What color would a solution of pH 6.4 be if the following 3 indicators are present? Phenolphthalein, neutral red, and methyl red. Ooh, there's a good name. Methyl red, like ethyl red. Methyl red. It doesn't matter. Yeah, sure. Yeah, assume they're all equal. Phenolphthalein is colorless. Neutral red is red. Methyl red is yellow. Therefore, the solution will be orange. Yes?
Is there any for a person in their right mind to do this?
Yes. If you take a mixture of indicators, you can create a universal indicator that will be a different color at every pH. Do you remember that pH paper you used for the titration? That's what it's used for.
Gotcha.
Yeah?
Yeah.
All right, now this is an actual lab that maybe we can do later, but we're not going to do because, you know, we don't get to have any fun because it's AP, so sorry. But you can do a lab where you have 3 indicators, HIN1, HIN2, and HIN3. And they are added to a spot plate containing solutions of HCl, NaOH, HA1, and HA2. So how many weak acids are we dealing with?
1, 2, 5, and
You guys have this on your book. You can look on your book if you can't read here. It's page 15, I think. Is it 15? 14, page 14. How many weak acids are we dealing with? Nope.
5.
5, yes.
All of it.
Okay, all of the weak acids and all of the indicators are weak acids. We also have in those solutions, if you have a weak acid, what else is by definition present?
Base.
Conjugate bases. And here's what happened. Oh, in fact, yeah, okay, so here we have HCl, and it turned indicator 1 red. It turned indicator 2 yellow, and it turned indicator 3 red. What form of HIN1 is red? Tell your partner. What form of HIN1 is red? Is it HIN1 or IN1 minus? Which one is red? Woo! If this is our equilibrium, what will adding HCl to that equilibrium do? It will increase this and it will shift it to the left. That tells us that which form of HIN is red?
Conjugate acid.
The conjugate acid form. So this form here is red. And that also tells us that for HIN2, which form is yellow?
Conjugate base.
Conjugate base. So the conjugate base is what? Hang on. For HIN2.
Oh, it's the conjugate acid.
Conjugate acid, yeah. Okay. What color, we're back to HIN1 again, what color is IN1 minus?
Yellow.
Yellow. Now going to IN2 minus. Now at IN2 minus, what color is IN2 minus?
Blue.
Blue. How about HIN3? Which form is blue? The conjugate base one. Okay, so that is blue. And HIN3 is red. Okay.
That's a strong half.
Now, when you add HA1 slash A1 minus to the indicator, HIN1, to the first indicator, so we're looking at our result here, is HA1 a stronger acid or a weaker acid than HIN1? Is HA1 stronger or weaker than HIN1? How do you know?
Because it's got similar behavior to HCl.
It's got similar behavior to HCl. We don't know if it's a strong acid, but we do know that it is stronger. Okay? So we're going to say that HA1 is stronger than HIN1. Does it make sense to put it this way? Yes? No? Okay. Never mind. We're going to come back to this later. Okay. Never mind. You know what? We got places to write things. So we can use all of these results to determine the relative strengths of all the acids from strongest to weakest. Would you guys like to try it without walking through the script first? To see if you can figure it out? It's like a little puzzle. See if you can figure it out. Little puzzle. Is there anyone who did not get the regular solutions review? Everyone got that? And Alvin, you need your quiz back, which I have put somewhere. Where's my lunch? Where's my lunch? Upstairs? Downstairs? Don't ask me. If I didn't knock, I You did well though.
Nice job, Alvin.
I think it was like you forgot to pay Jules for the ground for me, so that's not really a big deal. And then it was like 0.75 or not really something. If you don't know what to do, wave me over. If you're stuck,
What's HA3?
oh, I put another one in there just for fun. HA3, put it in there. Yeah. You have no idea what's going on. So, we can just put it. Okay. It is supposed to be Capricorn and base pair of they make together, they make one form in one color. So it's an acid. It's the base is going to rip off that side. Okay. So, boundary solving is and not just acid. Okay. If it wasn't in acid solution, concentration is high. There is kilograms to the left. And so yellow. Okay, in acidic solution. But with its equilibrium, we have lots of equal left, yeah. High, low, that's what so consider each species, and so the overall color will be yellow. Yes. Which makes it yellow. Okay, now, in a basic solution, you'll have to go with this. Let's just go with this. Yep. Okay. Now, the transition between the acid form and the base form is what the color will around you will be transitioning between the acid form and the base form. There's one every class, every year, there's always someone, I don't know. I don't know, there's always someone so dramatic, always grade 12, I'm like, really? Go talk to your kindergarten teachers, because they cannot do you well, okay. Anyway, so we have, the acid form is exactly equal to base form, we call that the transition forms. So we have the yellow equals the blue, that transition form equals the water. Now, when these two are equal, so it turns out that we have which one perfectly arranged the hundred value. Now, that allows you to find the KA points. It also allows you to find pH. She's going to do it.
Are you sick or are you just not? Oh, take the whole thing off.
Now this table.
You take a photo, bro. You can tell which side you guys was so deep. The more of this was yeah, let me
All right. Yes.
Correct.
I think so.
Alternating. In the bucket of the.
Yes. Okay. How that HCl is. It's strongest acid, so it's going to always be stronger than.
So the material's different.
Yeah.
So does it already cover it?
Stronger than. Anything that has the same as HCl will
Can
always
you
be
send it?
stronger than. Right? So now we try to say
Push it outwards, not here.
A1 is greater than I1, and I think it's down.
I don't even know. That's not my issue.
Yes.
Go, Aaron.
You could have silver here.
You know where you did it? I'm on my state. That's changed. Oh, yeah.
Try it.
It's like rocks. I don't know, it's something like eight. I don't know, you could ask me. It's not like, no.
It's not associated.
So not. I guarantee you. If you ask me. Brown nose and really young.
It's not, it's now like this.
Sad thing is no, but I'm still so talking. I don't have shades. Any elevation. Like, shades are gone. 4 meters. 4 or 5 meters. What do you mean is that it's not?
So I don't think you want.
I'm pretty sure. Are you saying this building has no screen?
Unless it's one like
that. If your screen itself.
Right, that's fine to get this strong.
Let's go.
I'll put you look at it. We're concerning about time. Like, what is he looking for? It's the same list. We got the same energy. I wish I could help, but I'm fully honest, I'm not 100% sure. Is this a what counts?
Okay, so and you see, so you know it there.
Right?
I agree. Carbon and so fast.
Okay, so HCl. And that being HCl1. So therefore HCl rate is from the
Now, this is.
but you know H1 is from the
What?
Because
Because not my fault, literally, there is, you get houses that end this why is it so weird?
which one that he's suddenly got is from
And then see if.
Hello.
You got the right. How do you do that? That's driving crazy. You said it was 100% accidental. You gotta find for this.
100% accidental, no way. No way.
That's two-handed. Bam! Back of the head. You're like, oh man, it's suspended. It was $5,000.
I know, still fine.
So why are we still at Tana? After the New York Rangers, you think
So
it's
the
a year.
And then.
Right, like, I don't
It
know.
operated. It sounds like we're gonna be about it.
I got.
Amos value one.
I didn't know you're right.
Then
Now,
then
saturated, but you want any.
then
Now, evaporated kind of with the concentration.
sample.
Yeah.
First, you look at the button and you're like, oh, HCl, that's right. I do HCl. Okay. Like,
What that is, the main sense is
This
evaporated.
is from a lot of stuff. Where's Darwin? Okay.
It is this.
Because it has no you know that this is from this from then that is
I have a really okay, I have a question. Can I just look at it as like when compared to
Yeah.
so obviously this was the strongest. And then since this one reacts with acid, I guess, or into that acidic color. Yeah. Okay. Oh, so you look at the strongest.
Yeah.
Okay.
Yeah.
Okay.
That's like always.
That would be strongest.
Pile of 400 of them, right?
Or not.
But it makes my production more productive.
I think it's productive. You're probably already working the box of it.
Okay, one. So this one. How do I?
Yeah, but.
I have gotten through.
This indicator.
I didn't know I just say my.
It's implying that it's.
I don't know why.
Oh, HA2 or HI? Okay, baby, HI2 stronger or maybe just good. I said it on the No, HCl is greater than. The color that it burns. You can't say red is greater than a child. That's what and then you know that stronger because yeah.
I don't know if you guys
If those weak
Dude, I don't know if that's a good idea.
Oh, and he wants all
He's in this really young.
And then you guide it. If you survive, you can be obviously.
Okay. So I think most people have kind of worked their way through this. Am I correct? Is that correct? We worked our way through this? Okay, good. Blah, blah, blah. This is just working you through it. So if you want to go through it, you can. There's answers in there. Okay. Ooh, weak bases. Page 23. To be honest with you, AP doesn't look a lot at indicators other than like their use in titrations. But, you know, the regular exam does, so yeah. Okay. Strong bases. What kinds of compounds are mostly strong bases? Strong bases are mostly what type of compound? Metal hydroxides. These fit the Arrhenius definition of bases because they release OH minus in solution. Can you think of an example? NaOH, LiOH, SrOH2. How many strong Bronsted-Lowry bases are there? 2. What are there? What are they? NH2 minus and O2 minus. Hardly any, so we're not going to really bother with them very often. There might be like a, oh, here's some magnesium oxide. What's its pH? Something like that. Yes? Oh, thank you. Ay, ay, ay. Okay. All weak bases are Bronsted-Lowry bases, which means that they are what? Proton acceptors. So for example, we have ammonia, which is a weak Bronsted-Lowry what? Base. And so it accepts a hydrogen, and we end up with NH4 plus and OH minus. With weak acids, we could cheat and leave the water out of the equilibrium because all weak acids fit not only the proton donor definition, but also Arrhenius, yes? So like if we had HCN, we could just say H plus CN minus, or we could say HCN plus H2O gives H3O plus plus Cn minus. Because when we write it that way, it can release a proton. When we write it this way, it can accept or it can donate a proton, yes? However, bases do not meet the Arrhenius definition. Let's try to make ammonia release a hydroxide. Apparently I was feeling feisty. Come on, I dare ya. Can you make ammonia release a hydroxide? Like where? Just no, right? Like where did the O come from? You cannot make it just release a hydroxide. So we're doing nuclear reactions now, are we? Perfect. So weak bases have to have water or another Bronsted-Lowry acid. Weak bases form an equilibrium. So guess what we can write? What do you think a weak base equilibrium has? It has a K, EQ, which we call KB. Could you please write the KB expression for ammonia? Is good.
Why is there a charge in your NH3?
What? Is there a charge on NH3? No. Okay.
That's right.
Now, we're going to talk organic chemistry for a moment, because at some point in your career, you will be looking at organic chemistry. Can you remember any functional groups? What is wrong with this pen? Hydroxyl. Hydroxyl. If we have a hydroxyl, what kind of organic chemical do we have? Alcohol. Carboxyl. I'm actually going to go with carboxylic acid. At this point, that is the COOH. The reason I'm not doing carboxyl on its own, because that leads us into esters, which we have not done. Okay. Carboxylic acid gives us carboxylic acids. And now, yes.
Is there an acetyl group?
No. I mean, yes, but it's not like its own functional group, because it requires there to be a certain number of carbons. Whereas a functional group is something that you just stick onto an any length carbon chain. Yes?
Are just H's in carbon, are those like all of the hydrogen?
Yeah? No. Functional groups are special things that give it a characteristic. Like alcohol makes it polar, right? Because it's going to have that, it can do hydrogen bonding, right? A carboxylic acid is also going to be polar at that end, and it will be able to do hydrogen bonding, right? Yes?
The
NH2 is a special one. And in fact, what we've got here is we have ammonia. These are all weak bases. We have NH3, C6H5NH2. We have N2H4. We have NH2. We have N, NH2, and NH. Those are all amines. So what do all the weak bases have in, what do the names of all the weak bases have in common? They end in INE, except ammonia. What do a large number of the names of weak bases have in common? Amine. What do the formulas of all the weak bases have in common? Nitrogen. What about oxalate?
Yeah.
Oxalate is an ion. Yes.
So, amino acids have an acid group.
Yeah, and they have a carboxylic acid group.
So, why so is it not the amine group that makes them a base?
Yeah,
Why are the amino acids acidic?
because they have a carboxylic acid group on them as well. They have an amine group and a carboxylic acid group, hence amino acids. Ah, so there's an NH something somewhere, and there's a COOH somewhere.
So it's kind of both.
It's both. Yeah. Well, no, it's not more acid. It's just, yeah. It's both. It's both. It's both. Now, if you've studied any organic chemistry, you might recognize a functional group. This is known as an amine, which consists of a nitrogen attached to other stuff. We have general categories of amines. You are absolutely not responsible for any of this, okay? Absolutely not responsible for it. I'm just making it easier for you to recognize a base, because often when students go into an exam and they're given a base, they're like, I don't know what this is, and then they start using Ka, and I'm like, oh dear God in heaven, don't use a Ka for a base. Do you know what I mean? Well, yeah, but you know, if you're given a compound and it's got these N groups in it, if you've never talked about amines, you won't recognize that that gives something basic properties, right? Okay. So general categories of amines, we have nitrogen with 3 hydrogens, hydrogen, hydrogen, hydrogen. We have nitrogen with 2 hydrogens, and what does R stand for? The rest of the molecule. It's going to be some sort of carbon chain, yes? There could be other functional groups on it, but we got a carbon chain there. This is what we call a primary amine. Okay, so if you've only got 1 carbon chain, 2 hydrogens, that's called a primary amine. If you have an N with only 1 H, that's called a secondary amine. Okay? Secondary amine. And if you have an N with 3 carbon chains attached to it, that is a tertiary amine. Do you need to know what all those are called? No. Okay? You just need to know that amines come in different flavors. So if you see H's, if you don't see H's, it's okay. All right? And amine, these amine functional groups are found in many organic carbon-based compounds, including amino acids. The acid part of the amino acid is another functional group called a carboxylic acid group, which gives us carboxylic acids. This organic terminology is not part of the Chemistry 12 curriculum, nor the AP, and it will not be tested. All right? However, if you're taking biology and things like that, it's kind of useful, right? And you'll be taking organic at some point. So having seen this terminology will be, you know, it'll make it a little less frightening. So here are how amines react with water. Hydrogen attaches itself to NH3 and we get NH4 plus. N2H4 becomes N2H5 plus. CH3N, the hydrogen attaches itself to the N. This would be would this be a primary, secondary, or tertiary amine? Tertiary amine. And it's got like a little double, a lone pair hanging out there. And so an H plus can come along and jam itself on there. Does that make sense, right? It would be the H plus would be like, ooh, I will share that with you. Thank you. Yeah? So it's that lone pair on the nitrogen that accepts the H plus. All right. Everybody just gains a proton and an H. Where do you put the hydrogen accepted from water in the formula? At the end. Could you write the equations for the following amines with water? Is good? Did I do them right? I just stuck another H on the N and added a plus sign. Yeah? Now, in our continuing story of finding pHs, look, the little old lady is back, but the weak little old lady shoos away the crows and picks up her bag of rice. Okay, so we're no longer having the crows going, "Caw." She picks up her bag of rice and makes it to home base. Oh. So if you have a base, what do the crows have to eat? They found some kebab that was lying on the ground. Kebab. Okay, so for a weak base, when the little old lady makes it home with her rice, they don't get to just eat the rice, they get to eat kebab. So you're going to use KB for a weak base. Do you know how often people write KAs for weak bases? It drives me bananas. Like, I don't know why. It's just like, especially when it says in the question, the following weak base, blah, blah, blah. Like, it's not even like you had to assume it was a base, and people will still write a KA, and it makes me so angry. So you, instead of making me angry, just remember the little old lady who makes it to home base, and the crows have to eat kebab, KB. Okay. I know I'm obsessed with this story, but there we go. So every time you're asked for the pH or the H plus or the OH minus or the POH, you have to ask yourself, is the solution an acid or a base? We'll throw in another option later, which is also a salt, okay? But we're not going to get there yet, all right? Is the acid or base strong or is it weak? If it is strong, what do you use? You use stoichiometry. If it's weak, you use Rice and the appropriate K, Kx, okay? Ka or Kb, depending on which one is appropriate. All right, calculate the hydrogen ion concentration in an 0.1 molar solution of the weak base aniline. You are given the Kb. Yes. Yes. No, you will not always be given the Kb in the question. Sometimes you will need to calculate it from the Ka, but that's for next day. Okay? Of its conjugate acid. So sometimes, especially if you're given an ion, you'll have to calculate it from the Ka of the conjugate acid. But we aren't doing that today. For today, I'm going to give you the Kb. Okay? If you have aniline, what do you recognize in the aniline? The NH2. You are also told, as if that wasn't enough, that it is a weak base. As a weak base, what must it do? As the base, it has to accept a proton from water, and water acts as the acid. Do you think you guys can fill this in? Do the question? Yes.
We assume that the X is
Yep.
but also
Do you know why people want to use a Ka? Often because it's they're asked for H plus concentration. And so they'll desperately try to make this equation give H plus somehow. And it doesn't because it is a base. Is it okay if we have something that gives us hydroxide? Can we find hydrogen later?
Yes.
Yes. So don't worry about what the question asks you for. Just worry about what the equation actually gives you. Yes. Yeah. Oops.
The thing is, they deleted the text. Yeah, but they deleted the text. So I have to go double check. It's just one of my normal fried rice.
Wait, but.
What? I don't know. I don't know what they did. I have to go out because they deleted the text.
Yeah, that was me.
Ja, nee, wordt ze vooral.
There was a text that said, Black Friday.
Yay!
So are we finding this unit easy so far? Ish? Kind of? Because it's kind of like the same? Yeah.
Right? Ja, dat is echt zo. Dit mag niet van de hele vaak heb ik oh, word ik ook echt zo.
En die Jim?
Ja. Ja.
Oh ja, een klein skip home.
I see this. You just have
Shall we leave it there for today? Because we only have like 2 minutes left or something? 3 minutes left? And you guys have a test tomorrow?
I'll